Hello everyone, welcome back to my channel. In this video I'm gonna talk about motion in one dimension. So this is probably like the first unit of AP physics and is the first part of IB physics, the topic of mechanics. So here is a list of learning objective that you need to learn today. So the first part is basically like different concept, vector versus scalar. So some of you might have already learned it because it's is also part of arrow and uncertainty in IB physics, and you need to be able to extract information from motion diagram, and then use those information you obtain to solve some problem, and you also need to know how to use mechanics equation, kinematic equation, and solve some basic problem, and you need to understand freeform motion. So first of all, let me talk about some a basic concept, vector and scalar. So for those of you who have learned it, just see it as a opportunity to review. So vector is a quantity that contain both magnitude. Contain both magnitude and direction. Right, and scalar contain magnitude only. So let's say here is a ball, and the ball is moving to the left at 3 meters per second. All right, then the direction will be to the left, and 3 meters per second will be the magnitude. So in another word, magnitude describes the size of a quantity, right? However, like writing all those words like to the left, to the right, can waste a lot of time. So scientists decide to use positive sign and negative sign to represent direction. So positive signs and negative sign to represent direction. So let me draw a simple coordinate system here. And usually the direction, the x-axis direction, or the rightward direction, also the east, are usually represented by a positive sign, and here is also always represented by a negative sign, like the opposite direction. In upward direction, the y-axis or the northern direction is always represented by a positive sign as well, and the opposite direction is always represented by a negative sign. But just be aware that your question might want to trick you, so it might say like the downward direction is positive sign. So just be careful with your question. And here is just a list of scalar quantity that you need to know. And here is a list of vector quantity you need to know. So for IB student, in the mechanic chapter, you will know all of those quantity and all of those quantity. So that's a lot. So just pay attention in your class, I guess. Displacement and distance. Obviously, displacement is a vector and distance is a scalar. So assume this is your starting point, right? And then you just walk to your end point, right? So this is your start. This is where you start, and this is where you end. Then the blue line represents distance, and the right line represent displacement. So displacement is the straight line between your starting point and your end point. And distance is the actual path, the length of the actual path that you take to reach your destination. So in mathematical language, displacement represented by our rho x is equal to your final position minus your initial position, right? So this is displacement is equal to initial x minus final x, right? And distance is just the blue line. So in some question, it requires you to know the pattern theory to calculate the displacement. So assume this is your starting point, all right? And then you walk to the left for a length of b, and then you move up for a distance of a. Then this line, the line in blue, actually the line in green, this line, c will be equal to your displacement. And your distance, let me write this in red actually, is equal to a plus b, right? Because distance is the actual length of the path that you take to reach your destination. So this is the start point, and this is the end point. So let's look at a example. A girl runs to the left for 3 meters and then goes up for 4 meters. What is the total displacement the girl will travel? So for those kind of problems, just draw a picture first. So 3 meters to the left and then 4 meters to the right. 4 meters goes up, sorry. So the displacement will be the length of the straight line between your starting point and your end point, which is the line gray. Oops. So you can use the theory you have learned before, like a squared plus b squared is equal to c squared, to figure out the displacement. So the displacement x will be equal to the square root of 4 squared plus 3 squared, which is equal to 5, right? There are some useful numbers that you will always see in your problem. So the first one is 3, 4, 5. Why? Because 3 squared plus 9 plus 16 is equal to 25, and then another one is 5, 8, 10, and then just any multiple of those two series number is you can use them as well, and you will probably see them in your question. All right, so here's a more complex question. In the coordinate system plan, a ball initially located at the position of 3, 6. After a certain period of time, the ball is being moved to the position of 11, 3 by winds. What is the total displacement traveled by the ball? So let me just draw a coordinate system first. So the initial position is 3, 6. So 1, 2, 3. 1, 2, 3, 4, 5, 6. And the final position is 11, 3. 4, 5, 6, 7, 8, 9, 10, 11. 11, 1, 2, 3. So the initial position is here, and the final position is here. So you need to find the length of the blue line, the green line actually. So how can you do it? Still use the theory we talked about. So here is this line here, the line in green. Actually, the line in red is equal to 11 minus 3, which is equal to 8. And then here, the blue line here is 3, right? So 6 minus 3 is equal to 3. And then so here, you just apply the theory, a squared plus 3 squared, and then take the square root, will be equal to your displacement, which is equal to, let me calculate that. Square root of 64 plus 9 is approximately equal to 8.54. So here is your answer. Alright, so now let's talk about velocity and speed. So velocity is a vector and speed is a scalar. And velocity is equal to change in displacement over change in time. And speed is equal to, so for speed is equal to distance over time. So in another word, what we can say is the magnitude of vector is speed, right? And because speed is a scalar, so speed is always greater or equal to 0, right? Because it cannot have a negative sign because it does not represent direction. So let's do an example here. A person runs to the left at 3 meters per second for 10 seconds. Then he turns his direction and right to the northern direction at 4 meters per second for 15 seconds. What is the total displacement and distance? So total displacement is equal to what? Well, let's draw a picture here. So run to the left for 3 meters per second for 10 seconds, and then turns direction. So what we need to know is here, this green line. So what is the length of this line? So the question says the person runs to the left for 3 meters per second for 10 seconds, right? So it will be 3 meters per second times 10 seconds, which is equal to 13 meters, right? Because the unit cancels. And then for here, similarly, it will be 4 meters per second times 15 seconds, which is equal to 16 meters, right? So this line, apply the theory, it will be this number. Take the square root, and it will be equal to, let me plug that in my calculator. Square root 67.082 meters. So this will be the displacement of this problem. And then how do we calculate distance? So let me write here. Distance, actually, it's okay. Distance so distance is the actual path, right? It's the actual path here. So it will be equal to 16 meters plus 13 meters, which is 19 meters, right? So now let's do the second part of the problem. What is the average velocity and average distance? This should be average speed. So average velocity is equal to changing distance divided by time, which is equal to 67.082 divided by, so 15 seconds, 10 seconds, so the total time is 25 seconds, which is equal to 2.68 meters per second. So this is the average speed, average velocity, I mean. And average speed. Average speed will be equal to 19 meters divided by 25 seconds, which is equal to 3.6 meters per second. Alright, so let's move on to the next part. Instantaneous velocity and speed. So instantaneous velocity, instantaneous velocity is the average velocity during an infinitely small interval, and because the time interval is so small that the time approaches to 0, so this is writing as a limit form. So some of you might have not learned calculus yet. So basically it means this, right? So here is the displacement and here is the time, and then the gradient here will represent velocity, so it will approaches to a very, very small interval, and so small that it approaches 0, so the instantaneous velocity will be equal to the tangent slope of the tangent line. Don't worry if you have not learned calculus. You will probably learn them in your math class later. So now let's talk about acceleration. So acceleration is a vector quantity referring to the change of the velocity of an object with respect to time. So here acceleration is equal to change in velocity over change in time, and change in velocity is equal to final velocity minus initial velocity. Same thing, there's average velocity, so is the velocity changes over a specified time interval with the SI unit of meters per second square. And instantaneous velocity is a velocity change at a specific instance in the time, also SI unit of meters per second square. So put instantaneous acceleration in a simple word is that instantaneous velocity is the average velocity during a very small time interval, right? Small time interval. It's so small that time approach to 0. So here it shows you how to write it in a limit form. Same thing, time is approaching 0 because the time interval is so small, right? It's so small. Same thing, instantaneous acceleration is equal to the slope of the tangent line. Alright, so now we are going to talk about motion diagram. So the first motion diagram we are going to talk about is displacement versus time, right? So there are like 3 diagrams in this picture. So let's think about what a diagram has, right? So a diagram has a gradient. A gradient means slope. And also we can say it's linear, non-linear, right? It has different relationship. And for slope, we know there can be both positive and negative slope. And now what we need to do is we need to think out of those mathematical relationship in terms of physical parameter, right? So first of all, what does a gradient mean? So gradient is equal to change in y over change in x. So in this case, is equal to change in displacement over change in time, right? And we know that change in displacement over change in time is equal to velocity, right? So velocity is represented by gradient of displacement versus time, right? So this is one of the important things we need to know. And now let's think about what does a positive slope mean, right? So positive slope tells us that velocity, right? Velocity is greater than 0, and negative slope tell us that velocity is less than 0, right? And then what does a linear slope tell us? What does a linear function tell us? So let me write this down. Linear function. So linear function has a constant slope, right? A constant slope means a constant velocity, right? And a nonlinear slope, and I mean a nonlinear function, means the slope changes, which means the velocity changes, right? So this is what we can know from a motion diagram of displacement versus time. So in this picture here, in this picture, it has a gradient of 0, which tells us that velocity is 0, which means that the object is stationary, right? So when an object has a velocity of 0 meter per second, the object is not moving, so it is in stationary. And this one, it has a positive slope, right? Positive slope, and it is constant, which tells us the object has a constant and positive velocity. And for this picture, right, it also has a positive slope, but not constant. Right, which tell us that the velocity increases, but not constantly, right? So it's not constant because the slope changes, right? So this is what we can know from the motion diagram of displacement versus time. And now let's talk about velocity versus time. Same thing, you need to know what does the gradient represent. So we know that acceleration is equal to change in velocity over time, as we have talked about, because acceleration refers to like change in velocity over change in time, right? That's just a definition. So and the gradient of the graph is change in y volume over change in x volume, which is change in velocity over delta t. So the gradient is the acceleration. This is super important, very important, this part. And then another thing to know is area under the curve. Can represent both displacement and distance. Right. So a horizontal line means that the object has a constant velocity, right? A constant velocity. Because the gradient Actually, not the gradient. Yeah, the gradient is equal to 0, so no change in velocity. And negative slope means the object decelerates constantly, right? Same thing, the gradient is less than 0. And for this one, the velocity decreases, but not constantly. Why is that? Because it can be seen like initially the slope is like this, and then but as the time increases, the slope become getting smaller and smaller and smaller. And for this graph, the velocity increases, but not constantly. Same thing. Initially, the slope is only like this, but as time increases, it's getting larger and larger. So let's do a very quick recap. So velocity versus time graph, the gradient represents acceleration, area on the curve represent displacement if we care about the negative sign and positive sign, and represent displacement if we do not care about positive and negative sign. So what this means is this is a velocity versus time graph, and you move at this velocity, and then right, so this part will be your displacement, but it will have a positive sign. But this part here, it will have a negative sign. So let's say the area here is A and here is B. So if you want to calculate the displacement, it will be A plus negative B, which is equal to A minus B. But if you want to calculate distance, it will be A plus B, right? So why is this area negative? Is basically because the change in velocity is negative, so the area will have a negative sign if you want to calculate displacement. So let's do an example real quick. Pause the video and do the problem by yourself. So calculate the total displacement if the y-axis represent velocity and the horizontal axis represent time. Alright, so I'm going to do the problem now. So basically you just need to calculate the area here. So I'm gonna calculate I will just so this shape is a trapezoid. So I will just calculate this by using formula. So here is 8, and here is A minus 5 is 3, and here is 5, right? So area will be A plus 5. Is it 5? I think it's 3. Right. A plus 3 times 5 divided by 2, which is equal to 11 times 5 divided by 2. So is 15 5 times 2. Actually times 1/2, I'm sorry. Which is equal to 27.5, I think. Let me just double check. Yeah. So let me check if the answer is correct. So the area of the triangle here will be 5 times 5, which is equal to here, and then this rectangle here, so here will be 2, so here will be 10. Right, and then here will be 2.5, so 2.5 plus 12.5 is equal to 15. 15 plus 10 is equal to 25. Calculate the total displacement if the axis represents velocity, the y-axis the y-axis represents velocity, and the x-axis represents time. So pause the video and do the problem by yourself first. Alright, so now I'm going to do the problem. So this problem is very straightforward. To calculate the total displacement, you just need to calculate the area. So let me calculate the triangle first. So the triangle will be half times 5 times 5, which is equal to 12.5. Yeah, and I will calculate the rectangle here. So here is 2, here is 5. So 2.5, 2 times 5 is equal to 10. And here is 1, here is 5 also. So the triangle will be 1.1 times 5 times 0.5, which is equal to 2.5. So just multiply them, not multiply, add them together, 2.5. You should get 25. So 25 will be your final answer. Cool. So let's move to the next example. Calculate the total displacement and distance. Pause the video and do the problem by yourself first. Alright, now I'm going to do the problem. So I will calculate the triangle first. So here is 20 and here is 16. Yeah. So the area will be here it will be 13 and yeah, 1,800. Is this correct? See, 12. I don't think this is correct. Oh, sorry guys. Here should not be. Let me just do this. So it will be 20 times 13, 600. And here, the area here will be, so here is 20, is it, oh, no. Example 2, calculate the total displacement and distance. Still pause the video and do the problem by yourself first. So now I'm going to solve the problem. So I will calculate the area of the triangle first. So here's 10 and here's 16. So the area will be 1/2 times 10 times 16, which is equal to 5 times 16. So it's 300 here. And then you can calculate the area here, right? So here will be 20 and here will be 20 here. I think here's 5. Yeah, 5. So times 10, 25. 16, 13 times 25, which is equal to, is this correct? Let me just double check. So if I calculate the rectangle here, it will be what? 5 times 16, I think. And here it will be 16 times 15 times 16. No, times 0.5. 16 times. Yep. Yeah, so I should erase a 0 here. Sorry for the mistake. And then let's calculate the area here. So here is 20, and here is 20, is 14. So the area here will be times 14 times 20, 4, which is equal to 400. So if you want to calculate the displacement, here will be a negative sign, so it will be 300 plus 750 minus 400, which is equal to 650, right? So it will be a negative sign if you are calculating displacement. Why? Because the change in velocity here, it will be negative. And then if you are calculating distance, you will just multiply all those three numbers together. Add them together. So 300 plus 750 and plus 400. Which is equal to 1,450, right? So this question might be a little bit challenging, but graph the acceleration versus time based on the graph of velocity versus time. So a hint will be think about the gradient, right? Think about the gradient. So pause the video and do this problem by yourself. Alright, so now I'm going to show you the answer. So this is the answer, right? So how do we do it? So we know gradient of those graph is acceleration. So gradient here is -3. So 1, 2, 3, -3, and here will be +3, right? So 3, 1, 2, 3, and then here will be -1, +1 actually, 1, and then the horizontal line means acceleration of 0. So you need to be able to know what gradient mean for all motion diagram, because they're all extremely important, right? So next one we'll do the acceleration versus time graph. So acceleration versus time graph tell us about a object's velocity. So we call the gradient a jerk. So jerk is equal to change in velocity, changing acceleration over changing time, and area under the curve just tell us change in velocity during a time interval. So you might wonder why the area means something. So let me just show you something real quick. So here is a diagram, right? And here's t. Let's start from velocity versus time. And then I will just draw a curve. So let's assume the curve has a function of f of x. right? And here the velocity changes, but not constantly. But we know that displacement is equal to velocity times time. However, because the velocity does not change constantly, so we need to use integral. So integral velocity times dt. And we know that integral calculate the area under the curve, right? You can just divide them into like different rectangle, and then it tells you the area. And that's why velocity versus time graph tell us about displacement. And same thing with acceleration versus time. So acceleration versus time. Acceleration versus time. So same thing, does not change constantly. But we know that velocity is equal to acceleration times time. But because it's not changing constantly, so we will use integral, where Riemann integral formula will be like a times dt. And same thing here, this integral is also calculating the area. And that's why area represents velocity. And yeah, so I hope this just give you a intuition of what area means and what calculus is, right? So find the change in velocity and the jerk. If you don't know how to do it, just go to the previous slide. By the way, I will post the PowerPoint in the description section, so I will post a link to this PowerPoint, but the PowerPoint does not like contain all of those annotation. Alright, so change in velocity, delta A times t. So basically it's just the area under the curve, right? So it's very straightforward. 4 times 9, 36. And for the jerk, it will be equal to 0, right? Why? Because like the gradient is equal to 0. Horizontal line means that gradient is 0. Alright, so for those of you who has learned calculus, so displacement to velocity will be the first derivative, and displacement to acceleration is second derivative. So why is that? So if you wanna have displacement to acceleration, you will convert displacement to velocity first, and then convert velocity to acceleration, right? So acceleration is equal to the derivative of velocity with respect to t, with respect back to time, and the derivative of velocity is equal to the derivative of displacement with respect to time. So it will just be second derivative. So in mathematical equation, this is what I mean mathematical equation. So there are several example based on calculus. Don't worry if you have not learned it. So the maximum acceleration attained on the interval of 0 to 3 by a particle whose velocity is given by this function. So acceleration is equal to derivative of velocity with respect to time. So apply chain rule. So for this equation, you know, like the function will open upward, right? So I don't know where 0 is, so I'm just randomly plot a 0 here. So assume here is 0, and then here is 1, here is 2, here is 3. Then you know 3 will have the maximum volume, right? Because it's open upward. So you just plug 3 into this equation. So it's equal to 3 times 9 minus 18 plus 12, which is equal to 21. So 21 is the answer. Let's do another example. Vertical position is given by this function. Calculate the acceleration when t is equal to 4. So this question is very straightforward. You just take the second derivative. So velocity is equal to the derivative of displacement with respect to time. So minus 12t plus 9, and the acceleration is equal to derivative of velocity with respect to time. So it's equal to 60 plus minus 12, Then you just plug in t is equal to 4. We have 24 minus 12, which is equal to 12. And 12 will be the answer. Right. So now let's look at those equations. So let me just wrote this down. So v is represent final velocity. We represent final velocity only in this picture. V0 represent initial velocity. A represents acceleration, and t represent time. And one important thing I want to point out is all of those equations works if and only if the acceleration is constant, right? So let's look more closer to the equation. So the first one, I will write v final as so this is v final. I just get used to write it like this, is equal to initial velocity plus acceleration times t, right? So t, so this is time, and this will be velocity. So here this point is your initial velocity, and then and here will be your final velocity. So to understand this graph, you can just see it from a mathematical point perspective. So initial velocity can be seen as the y-intercept, and acceleration will just be the slope, and time will be the variable, right? So the second equation, displacement is equal to VF plus VI over 2 times t. So the y-axis represent direction, velocity, and the x-axis represent time. So in this graph, let's say this is the VF and the origin is VI. So you find the average velocity here, right? And then you multiply by t. So basically the equation calculates this area. So, but from our previous study of motion diagram, we know this area. Oh, sorry, it's just my bad drawing. Let me erase something. So the equation calculates the blue area. From our study, we know the displacement is actually like this area in blue. So it's actually this area. So what does the equation exactly represent? So here's the trick. The area in green, so this area is equal to this area here, right? Because those two lines are exactly the same. So they have the same so they have the same area. They are equivalent, and this is what this equation represents. The next equation might seem a little bit confusing, so I'm just gonna do a proof for this equation. So delta x is equal to initial velocity times time plus 1/2 times acceleration times t squared. So in this equation, what is missing? Like final velocity is missing. And we know that displacement can be calculated by the area here, by the formula, right? By the previous formula we have studied. So, and we also know like final velocity can be represented as initial velocity plus acceleration times time, right? So we will just plug in this equation into this equation. So the blue equation becomes this. And then after you simplify this, it will become this equation. And this is how we get this equation, right? So for the next equation, let's also prove it. So final velocity squared is equal to initial velocity squared plus 2 times acceleration times displacement. So I like to use the letter x to represent displacement, but in the picture they use s to represent displacement, which is like the same thing. So in this equation, time is missing. So how can we represent time? Well, we have the equation of final velocity is equal to initial velocity plus acceleration times time. So times can be written as final velocity minus initial velocity divided by acceleration. And you can just plug in this equation into the equation of final velocity plus initial velocity divided by 2 times time. So let me do this. Actually, let me use s to represent displacement. So you can just simplify this equation a little bit. And then the equation becomes Vf squared is equal to Vs squared plus 2As. So you probably have learned in your math class that a plus b times a minus b is equal to a squared minus b squared, right? So now let's do that. So for IB student, they use a different letter to represent initial velocity. So u is initial velocity, and v is final velocity. A is acceleration, t is time, s is displacement, right? So kinematic equation from motion diagram, same thing. It's just what we have talked about here. Oops. Right. So it will be easier for you to memorize all of those equations if you can understand them from motion diagram. So here, motion diagram. It basically just shows you like how you can plot them. So I'm not gonna talk about this part because I've already proved all those equations. So let's do some example now. So when you are solving problem, because there are so many equations, I will recommend a few steps. So the first one is like label all the information, and then write out the question. Write out what you need to know, like what the question is asking, right? And then refer back to the equation. So here in the equation, how can you know which one to use? So if you have all of those conditions, you just use this one. But if they are asking you for time or acceleration, and you have like all of those conditions, just apply this equation. Like usually when you are solving problem, you need to the equation need to include like what you need to include, like unknown usually is 1, and all the other thing is like already So if I say I'm asking you to solve for time, and I know initial velocity and acceleration, and also know the displacement, you can just apply this equation. You're not gonna use this one because you don't know the final velocity, so there's no way for you to do it, right? So let's go back to the example. A ball rolls down 445 meters, so from rest. So here, this is a displacement from rest, means initial velocity is equal to 0 meters per second. Accelerate at a rate of 3.16 meters per second. Determine the time it takes to reach the bottoms and the ball's final velocity. So here is the acceleration. So let's calculate time first. Well, think about this question by yourself. Pause the video and do it by yourself first. Alright, so I will do it now. So we know the displacement, we know the initial velocity, and we also know the final, the acceleration, and we are asking to solve t. So the only equation that include all of them is this one, right? So now you can solve for t. So max minus times 2 divided by acceleration. Uh, 2 times minus initial velocity is equal to 0, so the whole thing is gonna be 0 here. And the acceleration is 3.16. And then plug in all of those numbers in your calculator. So 2 times divided by so time will be 26.5 0.54 seconds approximately. Alright, now let's solve for the final velocity. So what do you know here is you have another, you also solve for t, so you know the time. So how can you solve for VF? So you know final velocity is equal to initial velocity plus acceleration times time, right? And you know all of them, right? This one you know, this one you know, and this one you know. So you can just plug all of those numbers into this equation. Is equal to 0 plus 3.16 times 26.5454. So it is equal to 83.85 meters per second. Alright, let's do another example here. How far does a car travel in 45 seconds if it has acceleration of 0.32 meters per second? Assume it starts from rest. Still, when you are doing the problem, label out all the information you know when you are reading it, and then write out the quantity that you need to know. So how far is asking the displacement, right? So displacement is equal to initial velocity times time plus 0.5 times acceleration times t squared. Do we know this one? Yes, we do. Do we know this one? We do. Do we know acceleration? We do. So we can solve for displacement. So initial velocity here is 0, so this part is gonna be 0. And then plug in the number. Acceleration is 0.32 and time is 45. So let me calculate them. So it will be 324 meters. And this will be your final answer. Let's do one more example here. Actually, yeah, it's one more. And then we are gonna talk about free fall motion. A car travels 25 kilograms of a 15 trip at an average speed of 14 kilograms per hour. It travels second half of its journey at average speed of 80 kilometers per hour. A truck makes the same trip but spends half of its time at an average speed of 14 kilograms per hour, and the other half of its time at an average speed of 18 kilometers per hour. Which vehicle got there in the shortest period of time? So we just need to calculate time. So let's calculate the time for the first vehicle first. First car, right? So from the question we know the total is 25. No, the total is 15. 15 kilometers. And then it travels 25 kilometers at a average speed of 14 kilometers per hour. So what we can know here is here will also be 25 kilometers, right? So here will also be 25 kilometers. So we just need to calculate time for this part, T1 and T2. So from the question we know for the second part of the journey, it travels at an average speed of 18 kilograms per hour. So how do we calculate time? So time is equal to distance over time. Over average velocity, average speed. So for the first part, it will be 25 over 14, which is, actually I'm not gonna, so 25 over 14, 0.625, and for the second, T2 is equal to 25 divided by 18, which is equal to 0.3125, and T total, you just plus those two numbers together, is equal to 0.9375 seconds, right? So this is for the first car. Let me just erase this a little bit. And for the second car, we know that it's also 15 kilometers. And then let's assume the total time is t. So it's spent half of time at a average speed of 14 kilometers per hour. So here it will take 1/2 t, and here it will also take 1/2 t. So how can we express write out a equation based on the condition we know? Well, we know displacement is equal to times average velocity, right? And here in this question, let's say here's x1, here's x2, which is equal to x1 plus x2, right? So how can we express x1 and x2? Let me just move this up a little bit. Let me put it here. So x1, we know x1 has an average speed of 14. So I'm just gonna, and the time is 1/2 t. And for the second part, it has an average speed of 80. And the time is also 0.5 t. And the total displacement is 15, right? So now we can solve for this, just become a one variable equation. So 15 is equal to 20t plus 80t, which is equal to 60t. So t is equal to 15 over 16, which is equal to 0.83 seconds. So compare those two numbers. This number is smaller, right? So the second truck has a shorter period of time. So the answer will be the second car. Yeah. Just a reminder, if you assume the total time, if you assume half of the time for the second car, I mean for half of the time is equal to t, then your equation will become 14t plus 18t is equal to 15, and then 120t is equal to 15, and then t will become 0.4167. But you need this question is asking for the total time, right? So you need to multiply this number by 2, which also gives you 0.83. So do not make this mistake. Now let's talk about like free fall motion. So free fall motion is affected by gravity only, so the vertical acceleration will just be equal to negative g. And vertical velocity will be equal to negative g times d. Why? Because when free fall motion is like when you drop something, right? Drop something. So the initial velocity will be equal to 0, and the final velocity is equal to initial velocity plus acceleration times t, which is equal to 0 minus gt. So it's equal to negative gt. Horizontal velocity, 0. Vertical displacement, this is a very helpful formula to know. Why? Because we know displacement is equal to initial velocity times t plus a half times acceleration times t squared. And in our problem, because initial velocity is equal to 0, so it's equal to 0 plus minus, because acceleration is a negative number. So here should actually be a negative sign. Alright, so let's do an example here. Oops. A construction worker accidentally dropped a brick from a high scaffold. So when you see the word drop, you need to know the initial velocity is 0 meter per second. What is the velocity after 4 seconds? So here's t, and they're asking you find VF, final velocity. So final velocity is equal to initial velocity minus gravity times time, which is equal to negative 0.81 times 4. So it is equal to negative 38.24 meter per second. Actually, is 39.24. I mean, negative 39. Oops. This will be your answer. So how far does the brake fall during this time? So you need to calculate the vertical displacement here, which is equal to times times 4 squared. So it is equal to negative 78.48 meters. Right. So this is the answer for the second part. A tennis ball is thrown, so there's gotta be an initial velocity. At an initial velocity of 22.5 meters per second, it was caught at a distant bit above the ground. How high will the ball rise? So for part A, you just need to find the vertical displacement. So here is the ball. Initial velocity. How will the ball rise? And then you need to know like the ball will reach its highest point here, and then it's gonna come down, right? So highest point means the final velocity is equal to 0, right? So how can we do it? How can we solve the problem? So let's first see what condition do we need to know? So we know that final velocity is equal to 0, initial velocity is equal to 22.5, acceleration is equal to negative 0.81, and we just need to solve for h. So it's the displacement. So what equation can we use? Well, this can be a very super helpful equation, right? So negative sign because acceleration is a negative number, and I use h to represent the displacement in this question. So h will be equal to which is equal to 0 minus 22.5 squared over 2 times 9.81 with a negative sign, which is equal to, so the negative sign here cancels out. So it is equal to 25.803 meters. Right. So how long does the ball remain in air? So let me draw a picture here. So this is your ball, right? It goes up first, reaches its highest point, and it goes down. And because of the vertical displacement are the same, so the time for it to go up is equal to the time for it to go down. So the total time is equal to time up plus time down, which is equal to 2 times time up or 2 times down. And what we know here is the highest point is 0, and the initial velocity is equal to 22.5 meters per second, right? And we also know the gravitational acceleration is equal to negative 9.81 meters per second. So how can we solve for time? Well, time is equal to change in velocity divided by acceleration. So and here is equal to change in velocity over negative g, right? Negative g over g, I mean. So how can we solve? But is there anything wrong with this equation? Yeah, because time is always greater or equal to 0. So what we need is the absolute volume. So we need to have an absolute mark here. So time is equal to 0 minus 22.5 divided by negative 9.81, which is equal to, so this is t up, I mean. .325 seconds. So the t total will be equals to 2 times, which is equal to 4.648 seconds. This will be your answer. Alright, so this will be the end of the lecture of motion in one dimension. And please subscribe if you like my video. and follow my website, because there's more resource, there's more problem in my website. So follow my website. Again, thanks for watching, and have a nice day, guys.